Okay, welcome back. We're doing today the wrapping function, and one of the things what I wanted to talk about today was a particular family. So let me start right here. Oh, looking at this, what I've drawn is the unit circle. So we have a circle with a radius of 1. Now, since since we know that the circumference of a circle is 2 times pi times the radius, and we have a radius of 1, the circumference of this circle is simply just 2 pi, or the actual length would be roughly 6.28 units. Now, since the circumference of the entire circle is 2 pi, that would mean that the distance from there to there along the edge of the circle would just be pi units long. So what we're going to talk about first is this, the wrapping function. If you don't know what I mean by that, see the previous videos. Right now, the one I want to discuss is I want to talk about um, the pi over 6 family. So first, let's look at that. Literally, imagine on the unit circle. If I take the top portion of the circle and I divide it into 6 parts, that would be 1, 2, 3, 4, 5, 6. I divide pi into 6 equal parts. It should make sense to you then, if you think about it, if I go from here to here along the edge of the circle, I've gone 180 degrees. All right, so that would mean that if I've divided the circle up into 6 equal parts, that means that this angle right here would be a 30-degree angle. I'd have 30 degrees, 60 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees. So all of those would be 30-degree slices. So the first one I want to talk about is I want to talk about the pi over 6. So this distance right here would literally be whatever pi divided by 6 is. Now, I need to know the coordinates of that point right there. So what I need is the x coordinate. Nope, I just erased something. What I need, assuming this is the center, I need the x coordinate and I need the y coordinate. And there was the thing that I had before. And we also know that that's a 30-degree angle. So, since this is 1, again, see my last tutorial, but in that, the radius is 1 there. And I've turned it up so that's 1. Look at Look at the last few tutorials on the special right triangles, and you'll find that what I have is, if you're looking at a 30, 60, 90-degree triangle like I am now, 30 degrees, whatever this is, let's call this A. This is the short, there's a 90 degree. This is the short side. The hypotenuse is 2A, and the long side, the long leg of the triangle, is the square root of 3 times A. So for us, since this is 1, the hypotenuse, the long side is 1, I'm sorry, the hypotenuse is 1, that would mean that this would have to be a half, and this would have to be square root of 3 over 2. Go back a tutorial or two to look at the explanation of that if you don't understand it, but I'm going to apply it right here. So what that would mean is if I start here, I have to go over square root of 3 over 2 and up 1/2. So the way we would say that then is the wrapping function evaluated for pi over 6 would be equal to the square root of 3 over 2, comma, 1/2. That's what that would be. The way I like to think about it is, I would say commit these two numbers to memory, but don't necessarily commit to memory where they go. The way I look at it is, the square root of 3 over 2 is larger than 1/2 is. Check on a calculator and you'll see what I'm talking about. With a 30-degree angle like I have right here, I'm going to draw this triangle just down here. Imagine that I've started at the origin, okay, and I've turned my side up 30 degrees. Well, 30 degrees isn't very much compared to 90 degrees, it's less, which means you haven't turned up that far, so the x coordinate has to be longer than the y coordinate. And that's how I know that this one's square root of 3 over 2, and I know that this one is simply 1/2.